All right. Can everyone see my screen?
Yep.
Yes.
Okay. Yeah, so I'm going to be presenting on our paper about individual puck possession, part one, frequency, duration, and distance traveled. This is joint work by myself, Evan Iaboni, Sebastian Negulescu, Miles Pitassi, Fauzan Lodhi, and Tim Brecht. And yeah, as you'll see, the talk immediately after us is part two of this discussion. So there are a few questions that kind of drive this paper. Firstly, does possession drive individual success? And for the purposes of this paper, we define individual success using offensive measures of success like points, goals, assists, and shots. Kind of on the flip side of that is, do possession metrics offer insights that are not actually captured by traditional stats? So if the insights that are captured by possession metrics are entirely captured by, say, shots, then what's the point of even studying these? And then finally, we're interested in how possession dynamics differ across position groups. So we'll be looking at the differences between forwards and defensemen. There's a little bit of related work, but not too much. Our group has previously studied team possessions, and we found a correlation with having more offensive zone possession than the other team and getting success, which we defined as goal differential. There's also a study by USA Hockey for the 2002 Olympics, which tracked individual possession for some of the top players, but they did not really perform any rigorous statistical analysis on that data. And then finally, in other leagues, there's been a few studies on individual possession, and those mostly focused on tracking individual possession and looking at differences between position groups. Okay, I'm going to briefly introduce you to the metrics that we're going to be looking at in this presentation. So I'll note that we normalize metrics where applicable to 20 minutes of time on ice. This is just because certain players get more ice time per game, and so this is to make it fair. Additionally, we also only use 5 versus 5 ice time, and that's because we kind of theorize that power play shorthanded results in empty net situations will kind of create an unfair advantage or disadvantage for certain players that play more of those game situations. So our first metric is total possession duration. So that's total possession duration per 20 minutes of ice time. And then there's offensive zone possession duration per 20 minutes of ice time. And then possession count is the number of puck possessions per 20 minutes of ice time again. And then finally, average distance traveled per possession. So that's for each possession, on average, how long do you travel with the puck? So we use tracking data that's provided to us by the National Hockey League. This tracks the puck and the players. The puck is tracked 60 times per second, and players are tracked 12 times per second, but these are interpolated to uniform 100th of a second timestamps, and they identify X, Y, and Z coordinates on the rink. Now I'm going to define possession a bit rigorously. With the track data, we need to have kind of a precise definition. So this is the official definition from the NHL. There's kind of two cases. One is a sustained possession. So the start of a sustained possession is when a player has two consecutive touches of the puck. And the end of that possession is when the player loses the puck or another player gains possession. And then there's a different case, which is one touch actions. So examples of these are like shots, passes, and dump-ins, where the NHL defines these as possessions, but the player only very briefly touches the puck. And so it only constitutes like one touch of the puck, but it still counts as a possession. So we applied some filters in order to ensure that players had enough opportunity to actually get like reliable possession data. So the filters we applied were players needed at least 10 games played and at least 10 minutes of ice time per game, of 5 versus 5 ice time. So this left us with 671 players in the sample, or about 73% of all players. We're going to be looking at correlations a little bit in this paper, so I'm just going to briefly explain the interpretation of them. So an R value between 0.9 and 0.9 and 1 implies a very strong correlation. 0.7 and 0.9 implies strong. 0.5 to 0.7 implies moderate. 0.3 to 0.5 is weak, and 0 to 0.3 is none. And a positive R value means that it's a positive relationship, and negative means that it's a negative relationship. So we're going to start by looking at distance traveled per possession. The intent of this is that we are interested in identifying who's able to carry the puck long distances for their team. And so we exclude possessions that are less than 1 second because these are typically things like shots and dump-ins. And we don't want that to kind of influence the analysis here. We don't want players to be negatively impacted by that if they take a lot of shots. So these are the top 10 players in terms of distance traveled per possession. You can see at the top we have Matthew Barzal with 53 feet of possession every time he touches the puck on average. So that the interpretation there is that is kind of like blue line to blue line in terms of distance. The rink is 200 feet wide, so he travels about 1/4 of the rink on average when he touches the puck, and that's 15 feet more than the average. These are the top 10 defensemen. And from here, you can kind of see that it's kind of a similar trend where the top players have more than like the average. And there's kind of an archetype in the NHL of like a puck carrying defenseman. This kind of reinforces that archetype. You can see that the top players, there's variation, right? Top players do actually travel more. It's not all the same. So we think this could be useful for like grouping players into different playing types like puck carriers. And so comparing defensemen to forwards, we can see that forwards typically travel a bit further with the puck with about 38 feet, whereas defensemen are 33 feet. And that's statistically significant. Okay, so now we're going to focus on total possession duration. And so we're going to show tables and yeah, so here's this is the top 10 table for total possession duration. These are for forwards. There's 95% confidence intervals in green. I think that was also for distance traveled, but I forgot to mention it earlier. So yeah, again, we can see it's Matthew Barzal at the top. He has the most possession duration across all players. And compared to the forward average, he gets about twice the possession duration of forwards. This is the defenseman table. So again, we see the top players getting much more. In here, Quinn Hughes gets actually a lot more than even second place, Cale Makar. But even within this table, we can see Quinn Hughes gets 27 seconds more possession than the 10th rank. So much more than even another player who's at the top of the league. And of course, significantly more than the average. So we can see that there's a definitely variation in possession dynamics across players. And so compared to the forwards, defensemen tend to get more total possession with 49 seconds versus forwards who get 40 seconds on average. And again, the confidence intervals don't overlap. So that's statistically significant. Okay, so we measure success in terms of offensive measures of success, like points and shots. So we're now going to look at offensive zone possession, which we kind of think is going to lead to some hopefully nice correlations. And we, again, found correlations with offensive zone possession and success in our team's paper. So that kind of drives this work. So these are the top 10 players in terms of offensive zone possession. We can see that there's some well-known players like Connor McDavid, Leon Draisaitl, Nathan MacKinnon at the top. There's also a few lesser-known players here. So yeah, but offensive zone possession can kind of give us insights into different players, which you might not expect to be at the top here. And we can see, again, significant differences between top players and the average player. As you can see, McDavid has about double the offensive zone possession time as an average player. And comparing groups as well, forwards get about double defensemen in terms of offensive zone possession per game. So here are the offensive zone measures of success that we use. I'm going to focus on points. So as I kind of said earlier, there are some top players here, like Connor McDavid, but there are also players who are ranked a bit lower, and that kind of shows that offensive zone possession does not necessarily indicate that you're going to get a lot of points. We'll see in a few slides that there is a relationship between offensive zone possession and points, but it's not a strict relationship. There are definitely exceptions. This is a scatter plot of offensive zone possession versus points. In blue are forwards, green are defensemen, and there's a line fit in red. So again, we can kind of see the relationship between offensive zone possession and points. As you can see, forwards tend to get much more offensive zone possession than defensemen, but right there, there's Quinn Hughes with much more offensive zone possession than really any other defenseman. The second ranked one is Cale Makar there. So he's getting about 9 seconds more offensive zone possession, which is quite a lot considering he's only getting 30 seconds per 20 minutes. These are correlations between offensive zone possession and points, goals, assists, and shots. So within the position groups, we see weak correlations to moderate between offensive zone possession and shots for defensemen. When we combine the position groups, we see moderate to even a strong correlation with points. And this is kind of one of the main results of our paper is that offensive zone possession does correlate positively with points. But as we saw earlier, it's not a strict relationship. There are exceptions. So far we've been looking at 5v5 situations, and we're kind of interested in how the possession dynamics differ when we look at shorthanded and power play situations. So that's what we're going to look at now. We had to apply a different set of filters. And so our filtering was players with less than 25 minutes of power play time were removed, leaving 45% of players remaining in the sample. You might think that's not very many players, but many teams, they have a designated kind of set of players that they'd like to play on the power play. And so many players just don't get ample opportunity to play on the power play. So that's why so many end up getting filtered out. Similarly, with shorthanded, we remove players with less than 25 minutes of shorthanded time on ice. And that leaves us with 45% of players. These are correlations between offensive zone possession and success, as we saw earlier. Here we're looking at even strength, so that differs slightly with 5v5 because even strength includes things like empty nets. That's why the correlation coefficients are a little bit different than you saw earlier for that. But we see still the same trend of moderate to strong correlations in even strength. However, with the power play, we actually see a moderate correlation with assists and a weak correlation with points. However, there is actually no correlation with goals and shots. So this is a pretty interesting result, and I think there should definitely be more research into this as to why this is the case. But yeah, it's very interesting that there's a moderate correlation with goals during even strength play, but that actually just dwindles down to nothing for the power play. This is a cumulative distribution function of total possession duration. This is across all zones. So here we're plotting, starting with even strength. The forwards are darker and the defensemen are lighter. And I'm going to give a bit of a refresher on how to interpret a cumulative distribution function. So if you look at that dot there, the interpretation there is that 20% of defensemen get over 1 minute of possession per 20 minutes. And on the flip side of that, 80% of defensemen get less than 1 minute of possession per 20 minutes. So now I'm adding shorthanded, and we can see that perhaps expectedly in shorthanded situations, players tend to get less possession. Here's power play. This one's pretty interesting because it is kind of expected that players tend to get more possession on the power play, but there's such wide variance compared to shorthanded and even strength. So this kind of leads us to believe that top players are getting a lot more possession, but there's also a lot of players who just are not getting a lot of possession on the power play and are getting similar numbers to like even strength. So much more variation, maybe more dependence on top players when you're on the power play. Okay, so we've looked at correlations with possession metrics and success, and we've shown some tables. But now we're going to see if these metrics that we're looking at are actually useful tools for evaluating players by doing kind of a meta-analytics framework. So we borrow this meta-analysis from previous work by Franks et al. And we're going to be looking at 3 meta metrics here. Firstly, stability, which tells us how well a metric is able to remain consistent over time. So this kind of gives us um, interpretation into its predictive ability. And then discriminatory power is how well we're able to differentiate between skaters using just this metric. And independence is how much new information is captured by this metric that's not accounted for by existing metrics. This is our metric set. At the top left, you can see our possession metrics. And below that and to the right are existing metrics that we're kind of comparing against. So this is a scatter plot of discrimination on the x-axis and stability on the y-axis. And traditional metrics are in blue and our new possession metrics are in red. As you can see, our possession metrics all are kind of at the top right there. That's actually a very good thing. A higher score is better for both discrimination and stability. So they're very comparable to metrics like hits and shots, if you can read that there. So right at the top, very good stability and discrimination. This is a table of metric independence. So I'm going to kind of tell you how to read this. The interpretation here for possession duration is that it has an independence score of 0.6. What that means is that about 40% of the variation in possession duration is accounted for by other metrics in our metric set. Now, this is actually a very good result, 0.6. It's kind of moderate in that it's similar to about half of the metrics that we see, right in the middle ground. And so we kind of see that, again, moderate independence for all of our possession metrics. You might be wondering why points is so low. That's just because points is the sum of goals and assists. And so you can see shots there has an independence of 0.36, and giveaways is the highest in our metric set with an independence score of 0.8. So we did not see any metrics that got above that. So in summary, we defined several metrics related to individual possession. We showed top 10 tables as well as correlations. We found a strong correlation between offensive zone possession and points. And we evaluate our metrics in terms of stability, discrimination, and independence. And we found that they have very good stability and discrimination, and they also have moderately good independence. We'd like to thank Ben Resnick from the NHL's research and development team, Shona Eisen from Rogers Communications, and the anonymous reviewers who gave us very helpful feedback. That's it.
Thank you. Any questions from the audience? So I had a question. So I mean, I really like this correlation plot where you had time of possession and points per 20 minutes. So I assume then the top rightmost point would be McDavid then.
Yeah, let me bring it up. So you're referring to this plot?
This one.
Yeah. So the top point, yeah, you can see there at the very top with 1.2 points per 20 minutes. That's McDavid, yeah.
Yeah. So one question I had, have you tried to look at this condition on, say, the game state? So in the talk before, they talked about, okay, what if you're down one goal, or what if you're up one goal, or what if you're even? Does the plot look the same, or does other people end up being at the top there?
Yes, so we have looked at goal differential to see how the possession dynamics differ. I don't quite remember the exact results of that. It did not end up in the paper. But yeah, we have looked at it though.
Oh, okay. But the data, I suppose, gets a little bit sparser than perhaps, so a little bit noisier.
That's true.
Okay. Yeah. No. Thank you. And in terms of other thing that I was curious about is, so I mean here here you're looking at individual players. Have you tried to see if there's sort of differences in terms of team strategies that then show up? So I mean, in the tables, we start seeing some players from the same teams scoring high in the tables, if there's team differences.
So actually, you'll kind of see a bit of that in part two, where we look at how the possession dynamics within a team and how they kind of give possession to different players and how fair the possession is. But I actually think there is definitely opportunity for more work in terms of that, and I think that there's opportunity for like determining line combinations based off of who gets a lot of possession. So yeah, we've looked at it a little bit, but I think there's more opportunity for it.
Okay. Yeah. Thank you. So if McDavid and Draisaitl that both scores high on that one should be on the same line or not, I assume that. Yeah. Okay. So no other questions. Let's thank Evan one more time.